In my last video, I demoed Cypherly, a web app for sharing secrets. Before releasing that video, I wanted Cypherly available for people to use on the web. The process of setting up my dev environment and productionizing the app was kind of interesting, so I'd like to share it with you. Cypherly is a SvelteKit single-page app served by a Rust-based web framework called Rocket. There's several cool things about this environment. When running in dev mode, the Vite front-end dev server proxies API requests to Rocket so that we don't have to deal with cross-origin resource sharing. And auto-reload is enabled by default for both Rocket and Vite. This allows us to make changes to both front-end and back-end code and immediately test them. When running in prod mode, Rocket serves the compiled single-page app from a static folder. We use a multi-stage Docker file to build a minimal container that contains just our app. When all's said and done, the final container can be deployed to any serverless container platform, such as Kubernetes, Google Cloud Run, or AWS Fargate. So, in this tutorial, we're going to build a simplified web app called TimeGetter, which gets the time, of course, when you click the Get Time button. So, here's the roadmap. Initialize Rocket and build a basic API time endpoint. Initialize SvelteKit and build a page that calls the API time endpoint. Configure SvelteKit and Rocket to build for a prod environment, containerize our app using Docker, and finally, deploy the app to Google Cloud Run. So here's a new empty project called TimeGetter. We'll start by initializing Rocket. This command creates a new Rust app called TimeGetter in the backend folder. Setting VCS none skips creating a Git repo. Next, we'll add Rocket to our Rust project, and we'll enable support for JSON. We'll also add serde with the derive feature so that we can easily convert structs to JSON. And we'll add chrono so that we can easily create formatted time strings. Now let's open up the main file, and let's replace the contents with the boilerplate for our server. We'll have one route which returns the current time when you do a get at API time. This time struct derives serialize, which enables our API to automatically serialize to JSON. And here we are using chrono to get the time as a string in RFC 3339 format. Okay, let's start our new server. The watch command will reload the server whenever a file changes. Let's verify that our API is returning the current time. Additionally, if we refresh the page, we can see that our API returns an updated time and our time changes. Okay, let's leave Rocket running, and in a new terminal, create a new SvelteKit app in a folder called Frontend. Let's select Skeleton Project, yes to using TypeScript, and no additional options. Next, let's install the dependencies. Start the SvelteKit dev server and open it up in the browser. Okay, now we need to build our TimeGetter SvelteKit app. We'll start by opening up the main page and replace it with our TimeGetter front-end code. This is the TypeScript type for the time response from our API. It corresponds to the time struct from Rocket. Here we have our fetchTime function. This calls our endpoint and returns the response as a time object. Here we have our getTime button. When clicked, it will invoke our fetchTime function and assign the response to the time variable. Finally, at the bottom, we have our template. If time is not null, then it will be a promise. If the promise hasn't resolved, we print fetching time. If it has resolved, we print the current time. And if it failed, we print an error. All right, let's click the getTime button. Okay, there's an error. A hint at the problem is here. The API time endpoint is not found. The problem is that our API endpoint exists on the Rocket backend server, but we are calling API time on the Vite frontend server. We can fix this by configuring Vite to proxy requests to Rocket for us. Let's open the Vite frontend dev server config, and we'll add this proxy code. Basically, we are proxying all calls destined for API to our Rocket backend server on port 8000. Okay, that should do it. Let's click the Get Time button again. There's the time. Excellent. Note that we didn't have to proxy requests. We could have fetched directly to Rocket's host port, but this leads to cross-origin resource sharing errors. I find that proxying is a more elegant solution as it mirrors how the app works in prod. By default, SvelteKit assumes that a Node.js server is running to provide server-side rendering. However, that's not the case for us. In our TimeGetter project, we are using our own Rocket server, so we need to configure SvelteKit to render a single-page app instead. The first step is to install the static adapter. Next, let's configure SvelteKit to use the static adapter. So we open svelteconfig.js and just change auto to static. Now we need to configure SvelteKit's behavior. These magic values configure SvelteKit to operate as a single-page app. Let's save that file into source routes plus layout.ts. Finally, we can run npm run build and we should get our single-page app. And there it is in the build folder. Next, we need to configure Rocket to serve our single-page app. So let's reopen main.rs, and we'll use Rocket's built-in file server. Then we'll mount the folder called static into the root path. Note that this folder doesn't exist yet. We'll create it in a moment. Now, with this configuration, if the route does not match API time, then Rocket will attempt to serve static content. If no content exists at that path, Rocket will return a 404 not found error. There's one last thing to do in main.rs. When we deploy, Google Cloud Run will configure a port using the environment variable port. However, Rocket's port is configured via Rocket port environment variable. As a quick hack, we can just copy the port environment variable into the Rocket port environment variable before we call Rocket build. Now let's create a symlink called static that points to the built frontend in frontend build. Finally, let's launch Rocket and navigate to port 8000. There's our time getter being served by Rocket instead of the dev server. Click on Get Time, and there's the current time. Excellent! To get Rocket and our single-page app running on Google Cloud Run, we need to put everything into a Docker container. So let's create a new file and save it as Docker file at the root of our project. In this Docker file, we will have 3 stages. In the first stage, we will build the Rocket binary. In the second stage, we will build a SvelteKit single-page app. And in the final stage, we will create a minimal image and copy the important artifacts from the previous stages. Okay, so in the first stage, we build our Rocket binary. We start by using the Rust Docker image. Then we set our working directory to app. Then we copy our cargo files and our source folder to the stage. And finally, we run the cargo build release command. We can build the stage and inspect it. Let's run the docker build command. And then let's run the ls command, and we can see that the files we copied are there. And our time getter binary should be located in app target release. There it is. On to the second stage. In this stage, we use the node docker image. Then we set our working directory and copy our front-end config files, such as package.json, to the stage. Then we run npm install to install the node modules. Next, we copy the source code and any static files to the stage, and then build our app. Let's build the stage and inspect it again. Let's run the docker build command. This time when we run the ls command, we're looking at the files in the second stage, and we should see our build directory. There it is. Now for the final stage. So in the final stage, we're going to use distroless ccdebian12 as the base image. This provides the libc dependencies for our Rust binary. Then set the working directory, and now to the interesting part. We copy the time getter binary from the Rust image, and we copy the build folder from the node image. Then we configure the port and bind address for Rocket, and then invoke our time getter binary. Okay, let's test it out. So first, let's build the Docker image, and then run it forwarding port 8000. Let's navigate to it, and there's our time getter app running from our productionized container. Click the Get Time button. There's the time. Excellent. All right, let's launch TimeGetter to Google Cloud Run. There are a few prerequisites. First, you'll need to create a project on Google Cloud, and then you'll need to install the gcloud command, authorize it, and activate your project. Once you're done with those prerequisites, the next step is to run the gcloud command to submit our Docker image to Google Container Registry. This part takes a minute.
A few moments later.
Next, we run the gcloud deploy command, passing our TimeGetter Docker image. When this command completes, we get a service URL. And if we navigate to that URL, we see that our TimeGetter app is live. All right, that was my tutorial on building and deploying a Rust Rocket SvelteKit single-page app to Google Cloud Run. Now, that's a mouthful. Source code for TimeGetter is available on GitHub. You can find the links in the description. If you have topics you'd like me to cover, drop them in the comments. I'd love to engage with you. This tutorial was requested by my editor. Thumbs if you liked it, and subscribe if you want to see more. Thanks for watching, and I'll see you in the next one.